Ladies and gentlemen, mathematical induction. Okay, so for mathematical induction, very quickly, it's just about us proving that for the bottom case that we're going to have, once we prove that, we can also prove that the next step is also always true. And once we do that, we just basically saying that it's going to be always true for all the other cases. That's basically what mathematical induction is trying to do, okay? It can be more involved and, complicated than that, but let's just stick with the basis of it for now. So we want to prove that 1 plus 3 plus 5 plus, then we have plus parenthesis 2n minus 1, close it, is equal to n to the second power. So we want to prove that this side is equal to n squared, correct? So how do we go about it? So the first thing we got to do is we got to go for what we call the induction start. So induction start says what? So for the induction start, what we're going to do is we're going to take the a sub 1, okay? So that will be the first number that we're going to prove this one to be true or not true, all right? So that means what? So that means we're going to plug 1 inside the first equation here. So that means what? So once we get here, so we're going to go through this one here because we can, the 1, of course, is there, but we can go through here where the n is, and n is 1. So that will give us 2 times 1 minus 1, okay, equals to 1 to the second power. So we just basically substituting n with 1, okay? So there will be other cases where you cannot use the 1, but the problem will state so, okay? So this one is going to give us 2 times 1 is what? It's 2 minus 1. And then 1 squared, of course, is 1 times 1. So 2 minus 1 is equal to 1. Then 1 times 1 is 1. So this one is a true statement. Okay? And that's what we want. We want to make sure that we have a true statement. So that means the two numbers here are equal to each other. All right? So our induction start is being proven to be true. Now, the next step, so because the base case is this one here, which we just found that is true. So now we got to go to the next step to also prove that the next step as well is true. Following me? Okay? So now that's what we're going to call the induction step. All right, so we have induction start, and then we have induction step. So keep those in mind, okay? So what's going to happen? So that means if a sub n is true, that's what we just proved because this is the a sub n, which is true, then a sub n plus 1 also is true. If then, guys, remember that? Logic, okay? Logic math. So if a sub n is true, then a sub n plus 1 also is true. That's what we're trying to prove now, okay? So, and how do we go about that? So we go about, going back to this one here, so which is 1 plus 3 plus 5 plus . So we have plus, then we have 2n minus 1, right? Then the next one, which is n plus 1, so plus 2 times n plus 1 minus 1 equals to then n plus 1 squared. All right? So that's what we're trying to do. Okay? So if that's what we're trying to do here, so we end up with what? So we end up with knowing that this one here, ladies and gentlemen, which has been already proven to be true, is just equal to what? N squared. So this is just n squared. All right? Then plus, now we can work this one out to remove the parentheses. 2 times n is what? It's 2n. 2 times 1 is 2, right? Minus 1. That is equal to n plus 1 squared. All right? Everybody so far so good? You see how you can make this one lovely for yourself? All right, so now we can work this one out, combine like terms. So these are the two, so we end up with n squared plus 2n plus 1, which is equal to n plus 1. So at this point, there are two things that we can do, one or the other, okay? So that means we can factor this one to see if it's going to give us this, or we can expand this one to see if it's equal to this one. So it doesn't matter, whichever you feel more comfortable with, that's the one that you have to go with. So now let's say that I'm comfortable with factoring my problem here. So that means I have a trinomial. You can go back to our previous videos, solving trinomials. So you have trinomials here. So we want to find two numbers that will multiply, give us 1, and then the same two numbers add up gives you 2. So that is 1. So that is n plus 1 times n plus 1 should be equal to n plus 1 squared, right? Because this one is just the same thing as n plus 1 squared, which is equal to n plus 1 squared. All right? So this one also has been proven to be true. So that means, yes, our statement here is true. All right? So thank you very much.